Here we need to explain the concept of the coplanarity of two lines in space. So suppose if two straight lines are there in space, and how to show that these two lines L1 and L2 are lying the same plane. It means they are coplanar. So let's say the equation of the line L1 is given as r vector equals to a1 vector plus lambda b1 vector. And the equation of the line L2 is given as r vector equals to a2 vector plus mu b2 vector. So it means that A is a point on the line L1 whose position vector is a1 vector, means OA vector is a1 vector, and B, let's say B is a point on the line L2 whose position vector is a2, means OB vector that is equals to a2 vector. So therefore this will be the AB vector, and B1 vector is the vector which is parallel to the line L1, and B2 vector is the vector which is parallel to the line L2. So therefore here AB vector, that will be equal to A2 vector minus A1 vector. Since why? Since AB vector we can write it as OB vector minus OA vector. So here the lines are coplanar. So here B1 vector cross B2 vector we have to find. So B1 cross B2 vector is a vector which is perpendicular to the plane containing the vectors B1 and B2. So B1 cross B2 is a vector which is perpendicular to the plane containing the lines L1 and L2. So it means that AB vector should be perpendicular to B1 cross B2. Since AB vector lies on the plane of L1 and L2. Since why AB vector lies on the plane, AB vector lies on the plane it lies on the plane of L1 and L2. So now, therefore, we can say that AB vector dot B1 cross B2, that should be equal to 0. It means the scalar triple product of the vectors AB, B1 and B2, that should be 0. It means that A2 vector minus A1 vector, then dot B1 cross B2, that should be equal to 0. So this is the required condition for two lines to be coplanar. So this is the required condition for the two lines to be coplanar. So now, if the equation of the lines are given in the Cartesian form, Suppose if the equation of the lines L1 is given in Cartesian form, which is x minus x1 by a1, that is equals to y minus y1 by b1, that is equals to z minus z1 by c1, and the equation of the line L2 is given as x minus x2 by a2, that is equals to y minus y2 by b2, that is equals to z minus z2 by c2. Then b1 vector, which is parallel to the vector, which is parallel to the line L1, that will be given as a1 I cap plus b1 j cap plus c1 k cap, and b2 vector, which is the vector uh, which is parallel to the line L2, that will be given as a2 I cap plus b2 j cap plus c2 k cap. So b1 vector is the vector which is parallel to the line L1, and b2 vector is the vector which is parallel to the line L2. So now a1 vector, that is the position vector of the point A on the line L1, which is given as x1 comma y1 comma z1, and a2 vector is the position vector of the point B, which is given on the line L2, which is x2 comma y2 comma z2. So therefore a1 vector is x1 I cap plus y1 j cap plus z1 k cap, and a2 vector is the position vector of the point B, means a1 vector is the position vector of the point A, and a2 vector is the position vector of the point B on the line L2, that will be given as x2 I cap plus y2 j cap plus z2 k cap. So now therefore a2 vector minus a1 vector, so that would be equal to, OB vector minus OA vector. So that will be equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So then and b1 vector is this and b2 vector is this. So b1 a2 minus a1 dot b1 cross b2. So we need to find the scalar triple product. This is actually called as the scalar triple product. So therefore here a2 vector minus a1 vector dot b1 cross b2, that will be equal to the determinant of, we have to take the determinant of first the components of a2 minus a1, that we have to write, and then we have to write the components of b1, and then we need to write the components of b2. So therefore it will be x2 minus x1, means the first row will be x2 minus x1 and y2 minus y1, and then z2 minus z1, and this will be a1, b1 and c1. This will be a2, b2 and c2. So if we have to take the determinant of this thing, and that should be equal to 0. So this is the required condition in Cartesian form. This is a required condition in the Cartesian form for the two lines, to be coplanar. So suppose, for example, we can solve one example based on this coplanarity of two lines. So if the question is asked that show that the lines x minus x plus 3 by minus 3, that is equals to y minus 1 by 1, that is equals to z minus 5 by 5, and x plus 1 by minus 1, that is equals to y minus 2 by 2, that is equals to z minus 5 by 5. These are coplanar. So this we have to show. So now let's say this is the line L1 and this is the line L2, suppose. So now therefore the coordinates of the point A on the line L1, that means the position vector of the point A on the line L1, that will be given as minus 3 I cap plus j cap and plus 5 k cap. And B1 vector, which is the vector which is parallel to the line L1. So B1 vector will also have the direction ratios same as that of the line L1. So the direction ratios of the line L1 are minus 3, 1 and 5. Therefore, the vector B1 also will be minus 3 I cap plus j cap plus 5 k cap. And then for the line L2, the position vector of the point B, which is given on the line L2, that is A2 vector, that will be equal to minus I cap and plus 2 j cap plus 5 k cap. So then B2 vector, that will be the vector which is parallel to the line L2. So that will be minus I cap plus 2 j cap plus 5 k cap. Now, therefore, A2 vector minus A1 vector. So that would be equal to minus I cap plus 2 j cap plus 5 k cap minus of minus 3 I cap plus j cap plus 5 k cap. So that will be equal to minus I cap plus 3 I cap. So that is 2 I cap plus 2 j cap minus j cap. So that is minus j cap. And then okay, so this is then plus 5 j k cap minus 5 k cap, that will be 0 plus 0 k cap. So then therefore we need to find A2 vector minus A1 vector dot B1 cross B2. So that will be the scalar triple product of these three vectors. So that is equal to the determinant of, first we need to write the components of A2 minus A1, that is 2 minus 1 and 0. And this will be, so B1 components are minus 3, 1 and 5. And for the components of B2 are minus 1, 2 and 5. So that we have to calculate. That should, if that comes, if the value of this determinant comes 0, then only we can say that these three vectors are coplanar. So then that will be 2 into 5 ones of 5 minus 10, then minus of minus 1, that is plus 1 into, that will be minus 15, then minus of minus 5, that is plus 5, and plus 0 into something, that will be 0 only, or still if you want we can write 0 into minus 6, then minus of minus 1, so plus 1. So this will be 2 into minus 5, and this is plus 1 into minus 10, plus 0 into minus 5. Okay, so this will be equal to minus 10 minus 10 will be, so this will be actually, there is something wrong here. 2 j cap minus j cap, so that will be plus j cap, sorry. So this will be plus 1. Here there is something wrong, sorry, there is something mistake here. So here this will be minus 1 into this. So this is minus 1 into minus 10. So this will be plus 10 plus 0, obviously. So that is equal to 0. Hence, we can say that the two lines are coplanar since this determinant is coming 0. Simply, we can write that since the value of the scalar triple product, which is a2 minus a1 dot b1 cross b2, that is coming 0. So we can tell, so the given two lines are coplanar. And two lines are coplanar. Hence proved. Thank you.